Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. We have some implementation to do today. We want to make a little UI for fussing with stuff. We actually kind of know what we want to do because we sketched it out yesterday, just determining what actually we wanted, what we actually wanted the code to do and how we wanted it to do it. We sort of have an idea of that now. And so really what we want to do today is just like clean that up a little bit, in terms of just making sure it actually is what we wanted, and then figure out a way to get it on the screen. We sort of have the code for this already in the debug library, and so really what we're talking about here is we added some keys that allow us to like go into a debug mode here and we can select some things and stuff like that. And what we want to do is if we pick different things, and again, we're not really sure about a lot of this stuff, we're just sort of hacking it in there, and then we're going to see like what do we actually do when we've got it. And we can tune it a little bit to be more like what we want. But when we pick something in here, what we want to be able to do is get access to like a property sheet over here that allows us to edit some properties. And so in order to do something like that, we just need some UI. Now we have some UI, right? We've got like this stuff here that we did, and it does allow us to do some of this stuff. Like we can toggle things and stuff like that, right? So we actually have some things that allow us to do what we want already written. We just, we don't really have them integrated in to the game side of things. They're just in the debug library. And we kind of want this to be, even if you compile the debug stuff out of the game, we may want this in there. We really don't know what we want to do with that stuff long term. We kind of have to decide on that as we go, and I don't have a strong opinion on it. But what we do know is that an artist, for example, is going to need access to these tools. And that says to me that like the full thing that has like all this stuff, we don't want that exposed. Like an artist doesn't want to see this. They don't know what this means, and we don't want them to have to know what this means. That's a bunch of cognitive overhead for them that is meaningless to their job. Like nothing in here is going to help an artist get their job done. So all we're doing is throwing a bunch of new stuff at them they have to understand that literally is worthless to them, right? And so typically if we're talking about something that an artist needs to be able to use, we want to keep it to things that they actually care about, because otherwise we're literally just wasting their time. Their job and the thing that they presumably enjoy is drawing. They don't care at all about how many milliseconds a particular thing in the game takes. That's the programmer's job, and the artist should never have to care, right? And so what we want to do is we want to make something that an artist can use here and think about how that's going to work. And so it should be able to be something that with minimal amount of instruction, an artist can just remember how to do, and they don't have to learn a bunch of programming nonsense or things about the internal structure of our code. We don't want them to have to think about those things because, again, it's just going to waste their time, and it's going to get less art done for no reason. So what we want is something that's going to be art friendly and that will be in the game whether or not there is this debug system on at all. So let's think about that as we're kind of going forwards with it. But because we do have that debug code available, it does mean that we probably want to leverage the fact that we have that debug code, because since we have the debug code, it doesn't really make a lot of sense for us to rewrite everything when it's already basically doing what we want. So the question to me is more like, can we just take what we did here, turn it into sort of a more generic version that doesn't really care whether you're calling it from the debug system or not, and then use it in both cases, because it is basically the same sort of code. It's just whether or not it gets compiled in or not is more dependent on who's doing the calling. And so that's really what we want to focus on. So we created a thing yesterday that was a little editor system here that's the sort of bare bones version of what we want. And what we sort of did is we sketched in what we imagine it might look like to call this thing. And so here's an example of what that would be. And what we sort of did is we said, we imagined we could sort of make these sets of calls here specifically. So, I pick an asset. Here's an asset that I've selected. It looks at what type the asset is. And right now we don't have any sound or font editing because we don't really know what that means. Maybe it never means anything because maybe there's nothing really to edit on those. We don't know. But if there was something to edit, we could add it here. So really we're talking about just the one thing we wanted to edit, which was the bitmap type. And the only thing we really wanted to edit in there, at least at the moment, are these alignment points. And what we wanted to do is this set of operations. We want to be able to say, let's list an alignment point. Let's say which number it is in the file, right? Because there's 8 of them or 16 of them or something. I don't remember how many alignment points there were. How many alignment points were there? 12, something like that. Anyone remember? 12. So there are 12 alignment points in the file, right? So you could just specify any of those. So we're going to list all 12 alignment points. If an alignment point is empty, you can click on it and it will initialize it to a new one that's not actually set to anything specific. And then you can set it to whatever you want. And then in here, if we have one already, it will say the specification of it and allow you to remove that alignment point if you were so inclined. And that's really all we needed to do with alignment points for now. That's literally everything there is for us to do. There's a little bit more business involved in here that we're going to want to add a little bit later. It doesn't really have anything to do with the UI, but what we would want to do here is, because we know whether or not our alignment points, like we know when we add one, we know when we change the settings, and we know when we delete one. We may want that to be something that is saved on an undo-redo stack, and we definitely want it to be able to flush to a file. So we're going to have a few more operations that we need to implement. Those operations aren't really operations that relate to the UI, because those are things that, you know, would either be bound to a hotkey or are just going to use this button feature again, because they're just things that trigger, like save to disk or whatever. So they don't really affect our design of this too terribly much. So I think we don't need to worry about them at the immediate moment, although we could if we wanted to sketch them in. For example, you could imagine something like this. This is not a particularly good way to do this necessarily, but we could just imagine, well, and you know, we could even make it a fairly good way to do this, I suppose, if we wanted to. It depends on how we're feeling, whether we're feeling saucy or not. But we could have something like an in-game edit here, right? And you could imagine something that allowed us to build a little linked list of edits somehow, you know what I mean? And right now, maybe we don't know exactly what those are, but we keep a list of them. In fact, we could just do it this way. So you can imagine us keeping like 2 lists here, where we've basically got lists of in-game edits that we want to be able to track. So as we edit things, you know, we would save them as in-game edits that could be done or, you know, undone or redone or, you know, whatever we want. And at the moment, we really only have one kind. The only thing you can edit are these points. And then you can imagine us adding an undo and a redo in here. What that means is, at that point, once you've, you know, committed to having something fairly real there, which we could do pretty easily, then we can imagine what this other section might look like. So when you are in the editor proper, then when you come into update and render editor, if you're actually in any mode that involves editing at all, then what you could hypothesize is we would do something like, say, you know, if, you know, files are dirty or something like this, you know, something here that we look and we see whether the files are dirty, then we add a button that allows us to save, you know what I mean? And this would do the save here. And then we could also furthermore imagine, you know, some things about the sentinels here, the undo and the redo. So in that case, we would want something like if button, you know, undo, and if button redo, right? And these things here would probably have something to do, well, you know, these are the sorts of things that you want maybe muscle memory for, perhaps, possibly, I don't know. And so you might even say that these should be things that allow us to say whether something's enabled or disabled. So maybe it's more like that, right? And then we just say like undo only is there if the list is not empty, right? So if there is something to undo or redo, then these buttons would be available. And if there is something to save, then this would be available. And I think that would be mostly it. What I would imagine is that if you look at what's going on with these, we could probably do something where we would say, look, you know, the whatever the undo sentinel is pointing to as its next pointer, I think tells you whether you've saved. So like, yeah, I think it would be this. You would say, basically what we could do is say, look, whenever you save, whatever the undo sentinel is pointing to as its next operation, that would tell you specifically whether you need to save or not, right? Because if you undo back to the same place that it was at the time when you saved, then you don't need to save again. I think that's true. I'm making that up. But I think that's true. So you could do like, like that. We could also make these things be, you know, sort of more, we could make these things be a little bit more systemic here too. Just so that it's clearer what's going on. Because other people might want to call those. And really this is, you know, totally basic. It's just this. And so, you know, each thing here would be just a really simple way of checking which ones of these had anything in it. So here's undo available, here's redo available. And IsEmpty is also similarly super basic, right? It's just saying, look, I've got some edit that I'm pointing to here, and I can say if it's an empty ring by basically just saying if the next pointer points to me, right? So I can just say, look, the result is if the edit next pointer equals the edit, then it's just a single link sitting there by itself, so it's not a real list, right? And that's just a quick way of checking to see whether a W link list is empty or not, right? That's all I'm talking about there. Nothing fancy. We could also assert in that case that either the result is not true or the edit previous pointer also equals edit, because it would be illegal for the next pointer to point back to me and the previous pointer not to. That's just a bug. And so we probably want to also check that when we look and see if the edit pointer, if whatever the list is that we're looking at, in fact, you know, edit's not a very good name for that. I'm going to call that list for now, just so it's a little clearer what we're looking at there. So if the list's next pointer equals the list, then so basically this thing here equals true. Then if that was false, meaning this thing didn't point to it, then that's okay. But if it's true, then we need this to be true, right? I think I'm not phrasing that exactly right here for this check. What I want to do is say, like, either the better way to say that, and also, because I actually want to check two conditions here. I want to say either the result is true and, like, this result is true and this is true, you know, or not result and not list, right? I want one or the other of these two things. So either I have to have ListNext, equal to the list itself, in which case the previous also has to be equal to the list itself, or in the other case, if I didn't have that, then the other pointer, then the previous pointer also had better not be, because it's either empty or it's not in both directions. It can't be empty in one direction and not in the other, because that's just a linked list bug in our code, and we don't want that, right? So if we had something like this, then we can have we could have some kind of we probably want something like this. This is probably what we're looking for here, and I'm not sure exactly how we want to I'm not sure exactly how we want these to be specified. The thing that I'm worried about is, like, I can do the basics that would look something like this, but the problem with that is that all of these buttons would be really near each other, and some of them are really dangerous. Like, save overwrites the file, and revert would like undo all of your changes that you've done since the last save. And those are pretty dangerous things, and you don't really want them close to the undo redo buttons necessarily. You know what I'm saying to you? So we need to think a little harder about that. I don't know what the right answer is there, but we'll have to think about that a little bit more. Anyway, this is what we're basically looking at here, right? So if we then look at what's going on in the in-game edit, you know, tracking the undo and redo is really pretty basic. It's really just saying, look, what do we have for edits? At the moment, you know, we've got, I guess, really only one kind of edit, which is, what are they called? A line point edit? Yeah. And an align point edit is really basic. It's just saying, look, here's the asset index, here's the align point index, and then just what's the data, right? And it was like change from value, change to value, right? And so, you know, each thing we put in the stack can basically encapsulate everything into one of these edits that we have, right? Yeah, I'll call it that. Yeah, I'll call it that. Nah, I'll call it that. So, you know, in here we sort of got the various things that we want to edit here. And one of the things you can do in these situations to make things easier on yourselves in case you ever want a macro is you can just name the member the same as the type, right? And that means that people would only have to pass one thing as a parameter, and they don't need to pass the second thing because the type is the name in that case, and that can be handy. So we don't really need a type field here at the moment, but presumably someday we would. We don't know that we actually would, but someday, right? And so there would be presumably an in-game edit type, and that type would just say what was supposed to happen, right? So, you know, it would be like an edit align point would be the only thing in there. I guess there's an edit none, something like this. We can also just do it this way so that, again, everything matches, right? And I'll kind of show you what I mean by that in a second. So this lets us store this information. What's also nice about this is if we do it by index instead of by pointer, it means if you really wanted to and you were trying to be like crazy complete about this editor, you could save the stacks out as well. So like when you saved an HHA, you could have a section that was like, here's the edit stack too. So if people wanted to keep their undo stacks around, they could. Because this stuff is fairly stable, meaning it doesn't change based on where you loaded the thing in memory. which is kind of nice. So that's fairly complete, right? And what that means is in here, what we could do is we can have a way to edit these things. We could have a thing for align points. In this case, I would say, because it's so simple, I think the thing you want to do is just make this be virtualized, not the C way, but I mean just like, not virtualized. So what would the word be? Wrapped. So in here we would just do like edit align point instead of set, and all we would have to do there is, instead of passing the align point like this, we would instead pass the basic indices used to get at it. So we'd pass the asset index and the point index instead. And then the rest of the stuff would be the same as the align point setting function. And so in there we would say, okay, let's go ahead and grab out what those things were that were passed to set align point, like so, right? And all this function is going to do is just thunk through to that same call. We don't need that. With all of this stuff, right? But it's also going to do the work of capturing the before and after state, right? So it's going to say something like, hey, here's a new edit that we're going to use. So give me one of those. Maybe I don't know. I'm not sure. So in here we would basically say, hey, I want to capture one of these edits. Maybe this thing actually is a little bit squinky, and we actually do something like this. And then what we do is we say, all right, we're going to allocate one of these things, so this should come back with one of these. We want to capture the state of the align point first, so the change from value is going to be whatever the align point actually is at the time. Then we're going to set it, right? Then we're going to say the change to value is whatever it is afterwards, right? So this allows us to create an edit that will remember what's going on. We capture the state of the thing before the edit, we set it, we then capture it back, right? Whatever it's going to be. So we know what both of them are. And getting the HHA align point is pretty straightforward, right? It's just a thing that gets the asset first, like this, via this asset index, and then it gets the point index. Now, when we do this, we want to capture those two pieces of information as well. Right, we want to get those things captured so we can have them, remembered. And then these will capture the actual data that's important right here and there. So we want to be able to access this. What's interesting about this is when we do this edit align point, you can see kind of what's going to go on here. What we really would like is this to be a little bit more captured as well. We want to do a apply edit thing in here. Well, I'm going to hold off on that for a second. All I really want to do, I think, at this point is I want a way of this being a little more systemic. So what I'd like to do here is I'd like to have a way of getting that HHA align point. So what I'd like to do is I'd like to pass into this the stuff that you need, and I'd like to be able to get that thing out. So if I pass in an asset index and a point index, I'd like to make this stuff be known. So I don't have to do it every time, right? I just know I can get an asset, and then I know I can get an HHA align point from the asset using this. And then what I'm going to do is I'm going to say these all use that. Does that make sense? So that's pretty much how that would go. And then all of these folks now, if we wanted to do undo and redo on them, it'd be pretty basic. That's the entirety of the change, right? And that's pretty nice because that means that if we actually want to do undo redo, then all we have to do to implement that is we just have to have a... in fact, we can make this even a little bit more ridiculous by doing this. So if we want to, we can do this, which is in game change type, right? And in-game change type just has two things, like change from and change to. And so from is the 0 entry, to is, might as well be complete here, is the 1 entry, and so we know how many we need there, right? Makes sense? And so what we can do there is we can be even more ridiculous and make a single function that implements both undo and redo pretty easily, right? So what we would do there is first we need something that's like ApplyEdit, you know what I mean? Or ApplyEdit change. And what that would do is it would take the in-game edit in question and whichever one of these you wanted to do, right? So if you wanted to apply the from, you would pass from. If you wanted to apply the to, you'd pass to. Make sense? So at that point, all you have to do is pass the edit and that thing, and it will pull it out of the change and apply that. So it'll switch on the type of edit, whatever edit it is. It'll grab a line point as really the only thing. I think do we have a legal default case? Yeah. So in here, when we're doing our edit for align points, then that means really all we need to do is just take this thing and get that out. Once we've got that, then we can just apply the change using this stuff. So we're going to need to pass the game assets here. Presumably we want the, well, I don't know if we even want the editor. Maybe not. But we at least need the assets because we need to be able to access the assets out of there. I don't know if we need to pass the editor. Maybe we will, maybe we won't. But you can see here how we just say, look, give me the thing that I'm going to edit, and I do it. And then once I have that out, all I need to do is just assign whichever one they wanted me to assign, right? So in align edit, I can just say whatever this edit change is here. We could actually propagate these outwards as well. I don't know that I really want to do that because I'm not sure how that's going to shake out in the future. But all I'm going to do here is say, all right, whatever the type is, that's what we're going to apply, right? So that's it. And once I have that, I can actually implement my undo and redo kind of fairly trivially. You know what I'm saying? So if I end up in here, what I'm going to say is, all right, when I do this apply edit change, I need to pass the assets. I need to pass which in-game edit I'm talking about, and I need to pass which one of these I'm doing. Now, if I'm doing an undo, then I want to go backwards. So I'm trying to apply an edit change from, right? I'm trying to like apply what the edit was before the thing that I'm talking about. And if I want to do a redo, then I'm going to do the to, because I'm trying to put it to what it was after the edit. Because a redo is something that was undone and now needs to be redone. You know what I mean? So what I want to do here is say, all right, for the undo redo sentinels, all I need to do now is say, okay, let me go ahead and take an in-game edit, right? And I want to pop the first thing off of the undo stack. So whatever the editor sentinel is, I'm going to pop the first thing off of that stack, and I'm going to apply it, and then I want to push it as the first thing to redo, right? So I'm just moving it from one list to another and applying its change in that direction. Similarly, I should check here because just in case the list was empty, I know it's weird to say that the list would be empty because in this case, we're saying that you can only press this button if this was available. So maybe another way to do that might just be, let's make sure our system actually works cleanly and assert that it came back okay. Although this would crash right away, so I'm not sure that the assert is really going to do anything that it wouldn't have done otherwise, because it will just stop probably, but you know, either way. So anyway, same thing here. So if we want to redo, we'd pop this one, and then we'd apply the to change, and then we'd push it on, right? So that's the entirety of like undo, redo. And where's my isDirty? We didn't implement isDirty, so let me just kind of implement that real quick because it's really also very simple. So if I want to check to see if for the isDirty case, all I'm going to check here is to say, look, if the editor's undo sentinel has a next field that equals the clean undo sentinel, then it's clean. So I am asking if it's dirty. So it's just the not of that, right? So, I mean, more concisely, if the next pointer is not equal to the clean undo sentinel next, then it's not, right? So that's how we would determine whether or not it's dirty. Anytime you hit save, we're going to save the thing here. We don't really know what that's going to look like yet, so we're going to kind of leave that for the moment. But what we would like to do is say, when we do save, we do know that the clean undo sentinel next at the end of everything, we do want that to be saved. So whatever the undo sentinel was pointing to at the time, right, when we saved, we want to save that as our clean marker, because we know that that is the thing that means we don't have to save, right? So in either of these two cases, that's going to be the case. And we just don't know what those features actually look like yet. You know, so, and who knows, maybe we won't even have a revert. Maybe you just have to restart the game. If you want a revert, I don't know. We'll see. We could probably put it in there. Anyway. Well, actually, I suppose technically revert is just this. So if I was to say, if I just made these two be calls that you could make, I guess what I could say is, if that's undo, and that's redo, so, oops, don't know why I just did that. My head was thinking about the revert feature. So if that's undo and that's redo, then in theory, if you wanted to revert, I guess really all you're going to do is this. Right? I mean, is Revert just keep undoing changes until you get back to the place where the file was before you saved it? I mean, immediately after you last saved it, or loaded it if it's brand new. Um, I mean, I think that's actually all there is. I don't know. So there's a couple things here that we would want to do potentially. I'll just point them out. That we could implement a little bit later. And I'll just stick a to-do in there so that you can see it. It's basically a thing that says to do. We may want to group edits together so that undo can undo more than one change at a time. This facilitates undoing edit operations as the user perceives them rather than how they're implemented internally in the case of edits that edit multiple things at once. And so, you know, like imagine we have a feature that's like clear, that clears all the alignment points. If we wanted revert to undo a revert undoes the whole revert at once, you know what I mean? Then you can imagine wanting to create a bulk undo that's just like, here's all these in-game edits that are just, you can just chain them together, you know, if you want to, right? So it'd be really easy for us to implement that, and maybe we will. But I just wanted to sketch that out for you. Really, everything else is pretty straightforward, but there you go. So that's actually a complete implementation of everything. Except for save, which kind of needs to go through the asset system. We have the ability to write changes back, but we haven't really figured out how we want to do that yet. And so that's something that we're going to have to look at, right? So save we'll have to implement, but everything else here is pretty much sketched out now. So this does all the editing. It keeps undo changes. Everything looks good. So really, I think the only thing we're talking about now is we need some way of sketching in this UI. So what I want to do here is, again, I don't really want to talk about UI as UI. And the reason is because I don't really want I don't want to confuse the user interface of the game with the user interface of the editor or the debug system. So what I want to do is have like Handmade Dev UI.h might be the right word for it. You know what I'm saying? And Handmade Dev UI.h will probably look something like this, right? And so what I want to do is start gathering up the Dev UI stuff that I think you know, like something like this, you know what I mean? Where things that are clearly that I want in both systems, I'm just gonna start pulling them out of here and putting them into here, right? And then I'll force the debug system to go through this stuff, and that's how we will begin to use the same code in both places, right? So I'm just going to start only with the text output function. So this function here is obviously very useful. And I want to be able to do it. Oh, I keep forgetting I don't have my... I need to update my forcoder. I haven't copied my... Like, this is still an older version of forcoder. I haven't updated my forcoder to the new one. So I forget that I can't hit C to open the new file automatically. I can do that on the new one. So anyway, I want this text stop here to be shared. And so what happens is the things that can't be shared are like the debug state stuff. And the debug state stuff is necessary in a couple places for a couple things, right? So if I was to pull out all the things that I needed, it would look like this, right? And so in here, we would just say, look, is there a font instead of all the rest of that stuff? We would need a font scale. And we don't know where we're going to get that exactly. I guess we're going to get it here for the time being. So we got the font scale pulled out. What else we got for debug state? And then we've got like a shadow transform and a text transform. And those were just two things that were designed to put, because our stuff was being sorted, that was designed to put things in front of or behind, right? So like, you know, things got sorted into buckets where the shadows went behind the things that were in front of them. I don't know that we really want that anymore. We forced ourselves to do that because our renderer previously sorted everything. Our renderer no longer has to do that. It can just not sort. Like, you can just call it without the depth sort stuff on, and it will just render things in the order in which they come. So I don't really know that we want those two things, but I'm going to say that we still have them anyway. I think that's what called a render object transform or an object transform or something like that. Yeah. So we have a shadow transform and a text transform, I think, right? And those things were coming from here. And if we had some way of getting all of those, then I think, let's see. If we had some way of getting all of these things, then I think we are good to go, right? Because the rest of this stuff is self-contained. It looks up all of the rest of the things it needs using the asset system. And so it really needs, this is the set of information that it needs in addition to just the basics for you know, printing out stuff. So I also don't know if font scale actually does anything ever. We could potentially remove that, but you know. So the natural thing to do here, I would argue, is just say, like, make a struct that has exactly the things in it that we want. I mean, that's what we wanted, right? And you can imagine the version of this that gets made for the debug system. It would just look like a thing that copies those over. Right? But this is what you would need. And we could make that look like this, in which case it would just be that. Oops, sorry. But assuming that we filled all of this out, I also don't know why this font scale wouldn't be baked into these, but maybe that's not, I don't know, doesn't matter. Point being, if we have all of these passed through, this is basically like what we need to know for our like Dev UI Dev UI context. I don't know what you want to call it, but it's the thing that allows us to draw and do stuff, right? So if we just change this to saying we have a context pointer, right? And the context pointer is the thing that will get us all of these things. then we can certainly pass that out here. I don't know that render group, I don't know if that wants to actually be a pointer there or not. It may want to just be one of these, but I'm not sure. So for the moment, we'll leave it as a pointer. It's fine. So we're going to do this, and then once we grab all those things out, we're good to go. That means that in our startup, we would need something that basically does this for the debug system. You know what I'm saying? So something that would prep one of these. I don't know how we want to... I kind of like that as a word, but DevUI. But I'm going to actually capitalize it because camel case, if you're in for the camel case, you might as well keep it going. So we would want to do... oh, what did I do? That was totally not what I wanted. I got carried away there with the word DevUI. There we go. That's what I actually wanted to do. So we could do that. I don't know if we want instead to do this. I mean, that's another option. Right? Maybe that makes more sense. But the reason that I'm not as interested in that, the reason I don't love that, is because I could see Dev UI being its own thing that stores like state and stuff. So the Dev UI context is more the thing that's like a drawing pass, you know? It could be alternatively called Dev UI pass. You know what I mean? So I don't know. So if I were to go that route with it, then inside the debug system, and anywhere that previously someone was, so like, you know, inside, just go grab like inside the debug, you know, startup stuff. Then what we're going to do is in both of these places, like in the debug system where they're no longer necessary. Are they really? Yeah. Is that actually true? I mean, they're getting used. Are we sure they're not necessary? All right. Look at that later. Anyway, so in here, we know that we need one of these things, and we, you know, so we know we need one of these Dev UI contexts. And we know that we want to initialize that. So when we do our like debug startup stuff, right? So everything gets initialized. Once we have everything ready to go here, I want to create one of these things. So I want to say like Dev UI context. You know, does that probably wants to be that. So if I've got one of those, once I grab it, then I want to be able to fill it out here. I've already done that. That's what it is, right? And so that allows me now to call this call anytime I want to. Let me go ahead and pull this out here. And then the text op is just the same thing, but it's, you know, it's the Dev UI stuff. And that's about it. So there's Dev UI text op thing. And in here, we would have to do this. And so now what we need to do is actually provide those things to the system, because obviously, you know, the debug system Here we go. So in the debug system, these things need to be included somewhere. Just want to see where those actually get included. All right. So I guess inside handmade.h, we can just put those in here. I'm not sure where they should go at the moment. I'll put them in here for the moment. And we'll sort of push from there. Oops. What's going on? There we go. So I can just predefine that because that'll get defined a little bit later. I don't know what else isn't there. Did we end up with this in the wrong place? So we've got devui.h and devui.cpp. So I must have just had a typo. Oh. Okay. Looking at these, this should probably be called font info. So let's keep going from there. This is actually the get asset stuff. And okay, so we have, this is actually all in the other code, which I don't really want to deal with right now. So I think probably what I'll do here, excuse me, is I'm just going to nuke all of this stuff. While I just verify that we didn't break anything. Sorry, that's behind my head there. I can't see it either, but I don't need to because I'm just making it a dummy function. And so all I'm going to do is just nuke that because I don't want to look at those errors yet. I want to look at these errors first. So what I want to do is make sure that the debug system still works and can use that same system, like can use that thing we pulled out and draw properly, because that's what I want to focus on first. Make sure all that's working. I don't need that part of it. There we go. That's actually font info. What is this? We must have accidentally deleted that. And this is just because we need to do this, right? So I think that's good. And so now we can call the text out thing from anywhere, and you can see that it's still working just fine. So that's good. And what we would like to do probably is move some of the other font stuff out into there, like, you know, the tooltips and stuff too. So I think we want to like the tooltip buffer to be there too, would be my guess. So we can see what we want to do about that in a second. We'll think about that a little bit more later. All right, So now let's take a look back to the in-game editor, because now that I pulled that function out, now I want to debug this thing by stubbing out these other pieces and kind of going from there. So let's start by getting all of this stuff compiling and stubbing out the functions that we don't have yet. So here, this getAsset call, that looks like it returns a memory header. I'm not sure why it does that. I'm not sure why it returns a memory header. So I'm going to look just so I can find out why, right? So it returns a memory header. Because it affects which one was the most recently used. So this really isn't getAsset per se. It's really getAsset memory header. Which I may update it to reflect. This is the actual getAsset call. Why these are inline, I have no idea, but they just are. So that's actually what we wanted for getAsset, and this is getAsset memory header. They're definitely different. And so these calls here really should be getAsset memory header. In here we need the actual bitmap, so here we should do an assertion that this asset is in fact a bitmap. That's actually correct. So we want the HHA inside, we want the actual file information, so we want that. Let's see what else. Align, point, edit. So we need this to exist. So what we want to do here is we want to have a way of having the in-game editor allocate change lists, and they never go away. So those things, basically these are allocations that are never freed, ever. You just want to pile them up for eternity. We could try to recycle them if we get too many of them, but hopefully we would never get too many of them, because you really don't ever want your undo list to go away. So you want to just keep piling them up until virtual memory hits, right? Which is a lot of edits. So the in-game editor here, when we do an allocation, we want to allocate by type. So what we really want to do here is say we need two things. We need the type of change you were doing, right? The type of edit you were doing. So this is the type. And then we also need well, I guess that is the only thing we need, because the size doesn't change, it's a union. So we've got a result here. The result is just going to be a push struct. I could say it's an in-game edit. You know what? No, I don't want to do that. I'm going to do it as a U8. We'll see why in a second. So if I take the in-game edit here, and I just say, well, even that I don't have to do. Yeah, it really is just a void star. Anyway, so if I take the in-game edit here, and I just say, look, I want to take the, I want to make one of these. I need some like undo memory here, right? Like this is the undo memory we're going to use. So I want some undo memory. I know that it's going to be this type, so I'm going to push one of these in-game edit structs on. You know what? I changed my mind. I am going to do this. So we're going to do one of these in-game edit structs. When we get the result back, we're going to set the type equal to the type that we're told. And we don't want it to actually have any membership yet. It's just kind of hanging out as its own list. So its next and previous pointers just point to itself. And that's all that happens. So then we can return it and it's good to go. I think that's everything. And so then I just need a pound define cure that'll do the thing that I wanted to do with the type. So what I want to do is say whatever the type is that you're trying to push on here, I want to allocate one of those by passing the type here with this prefixed to it. And then I'm going to also cast to that type. So you can see why I wanted this to be that thing. Oh, not cast, sorry. I want to reference that type. So, like this. Right? So I'm going to basically get you the address of that subfield. And I'm also going to use that to pass type. So that's why I named it the same, because then you can just pass one thing to the allocate editor edit and you get the right member and the right type field assigned for free, right? That's just a little convenience there that helps keep things simpler for everyone who's calling you. So we need some undo memory. What else do we need? Point index. You're telling me that's not a thing? It's a line point index. All right. This is change type from edit change from, and this is edit change to. What else do we got? Should just put this undo memory in there. So if I want some memory for this sort of thing, I should be able to create one of these memory arenas just from whole cloth if the in-game editor is going to be here. I should be able to say that there's in-game memory, or I should say undo memory here. And that undo memory should probably be clear to zeroable. I want to say. I don't know. We'll find out. So we also want it to be non-restored memory. So I would like to initialize that because I would like it to be non-restored memory if possible. You know what I mean? So I want the allocation parameters for it to be platform memory non-restored. I don't think there's anything else that you really need there. So, you know, we could just have it so that the memory arena's allocation flags are just set to that. So I think when we call in and the editor actually does anything, I mean, we should be able to do this. So we can create an init call that'll do it at some point. In here, this all looks fine. Looks like I was pulling off the wrong struct in a bunch of these cases, other than that. So now we sort of have a couple... Looks like it wants an actual point on these. So that. I like bitamp. Bitamp sounds like some kind of a like chiptunes editor. So it looks like now we're down to just unimplemented functions, right? Which is where we want to be. So I think that's everything that we wanted there. I'm going to pop over to Dev UI, and I'm going to stub those functions out real quick. And then we're going to have to start working on the merge. Which will take a while. That's a label. There's an enabled flag. There's the stuff that allows us to kind of pick those pieces apart there. Here's our editables. So these are things that we would pass addresses to because the person who's calling them needs to be able to change them. So and then we also had it at PXY. And this one took bounds, so you kind of knew what the range was that you could move it in. All right, so did I miss begin section? I did. All right. So I think that's all the functions we're calling at the moment. Let me see if that's true. There might be a couple. There's a couple in the other thing where that's not true. This is all the UI functions we're calling, but we have to implement one or two functions in the actual section needs a, I see. But anyway, sorry, I got distracted there. There's a couple things in the actual adding things and removing things from the list, stuff like that we didn't implement over there actually. So technically that's not, there are a couple of other functions that we need to define, but I was talking about, I think we got all the UI functions we need to define. I'm not sure what the problem is with begin section. Where is layout? I guess layout doesn't exist is the problem. So I'm going to make it exist. We need button to have a default parameter. So if you don't specify false or true, it's just always assumed to be true. That's true. So edit align point actually needs to take the asset index and the point index. And that will have to take the assets as well. So how many arguments does it take then? So it takes the editor, but we don't know why. Oh yes, because it needs to allocate something. That's why. We probably should just have the assets attached to the editor because we're having to pass them around everywhere here and it's not something that changes. So we should probably just nuke that and have that be accessible from the editor itself. Seems like a sort of more sensible thing to do. So yeah. So now we get down to some of these things here. Pop first, push first. Those are things that should be pretty straightforward to do. So let's go ahead and put them in there. So what we want to do is we want to have a pop first call that takes whatever the link is that you're looking at previously, it takes its next pointer and pops that off. And so what that's going to do is first of all, assume that there isn't something. It'll check to see that it's not circular, so it's not like a little, or I should say a nub, like just one thing. And assuming it's not, then it will actually like unlink whatever that one is that's after it. So it'll unlink previous next, right? And return that. So it'll just unlink this one and it'll return that one as the result from the pop first. The push first doesn't really need to check anything because it knows it's going to actually do like that sort of thing. So we want to just do the link like so. And so on here, we'll just have our two basic linked list functions, link and unlink. Something like this. So if we want to unlink something, we only need that thing. And if we want to link something, we need to know where to link it in. So if we want to do the unlink operation, all we need to do is say whatever the thing was that was before us is now going to jump and point to the thing that was after us. And similarly, what we're going to do in the reverse case, right, is similar, right? So we're going to take the previous thing and make its next pointer point after us. We're going to take the next thing and make its previous thing point behind us, and then we're done. Then we just want to sort of get us linked up to ourselves, right? If we want to link something in, then we need the previous next pointer to point us. We can do this a little bit more cleanly, though, in a second. So we'll do that a little bit later. What we want to do first is set our previous pointer to our previous. We want to set our next pointer to its next pointer. And then we just need to say our previous next points to us, and our next previous points to us. And then we're done, right? So we just say, look, we've got one thing. We want the thing that points to the thing behind us. Well, we know what this is the thing that's supposed to be behind us. The thing that's in front of us is whatever was in front of the person who was behind us, right? Because we're going in between him and the thing that was after him. So that's what we do. And then what we want to do is say, all right, take the previous next, point it to us, take the next previous, point it to us, and now we're fully linked. So once we've got all of those operations in there, we're good to go. We got a couple of little things to clean up there. Push first here needs to take the actual thing to push. We, for some reason, omitted it. So in both cases, it's got to take the edit that we were trying to push on. We, for some reason, don't have our begin line. Begin line takes a Dev UI layout. Why does that not work? Oh, because we don't have one defined yet. So in here, we need to do a Dev UI layout. We don't actually have one yet, so nothing's going to happen, but we need to have one to start with. We need to get editable type working. We'll do that in a second. And then the layout itself has to get passed down in here, and we'll do that. And the problem there is that the address here is some enum, and we need that enum to be compatible so it can be edited. So it kind of needs to be like a U32 there, right, that it can change. And that's not super safe, but I don't really care. All right, so the only thing I really wanted to change before we start integrating that in is I do want to have a Dev UI edit block here, and I do want that to come back like this, and I want you to have to do that. We'll see why in a second, but basically I want to reserve stack space so that I can keep the change stack and have nested edit blocks if I want to, so I want you to have to do a block for that. And so when you do begin an edit block, I want you to, in here, write begin edit block. I want a Dev UI edit block. I want to basically have you have to do that. I could also actually have you do that because then you don't have to use the ampersand. That's probably better. So, you know, something like that. So I did want a little change there, but otherwise we're okay. And we'll see, like I said, kind of why I want to do that when we actually go to implement that. All right, so I think now we should be running the exact same as we were before. We have all of our editor functions implemented effectively. And in theory, we could actually start even editing our points if only we now had the stub functions wired up to these functions that we already have. And we sort of got part of the way there. By pulling out into the Dev UI, we pulled out the text function, so we can draw text now, but what we don't have is any of those other features. So if we look back, for example, at the Debug UI, we don't have any of the interaction features, and we had layout features. Here you can see them, right? Like that we're trying to do layout functions, and we don't have any merger of those two things yet. And the question is, how much of these do we want to merge? I'm not sure. My suspicion is we more or less want to merge them completely. In other words, if debugui.cpp kind of goes away eventually, that would, I think, probably be a good thing. Because if you just look at what's in there, it's mostly all stuff that is valid in both places, right? Like, there's a couple things here that are sort of not really maybe exactly what you would want, but to a large extent, it's pretty darn close to being the same. So we should be able to merge these in a way that isn't too onerous. And a lot of, like almost everything here is the same, right? Like almost everything here is what you would want as you're sort of making these things happen. So, I would assume that for the most part, we want this stuff to kind of merge up, right? And, I'm looking at this stuff. So when we actually do layout elements, they exist really only on the stack. It looks like too. So again, I think a lot of this stuff really can be. I don't think much of this stuff really has to be modified. What of the things in here do we actually have that are like we can't even. I feel like the tear off features and stuff that we had, I don't really know that we're even doing those anymore. Yeah, I'm not sure. But looking at these, right, we've got all these things that look a lot like stuff we would just keep, I mean, it really just looks pretty much the same. I mean, it looks the same to me anyway. So I feel like most of that stuff is pretty much okay. So looking at this stuff here, debug interaction looks pretty good. I'm kind of interested to know. So let's suppose we started plucking away at this thing. I just want to know, like, to what extent. What are these things used for? Because I don't really know anymore, right? We implemented them a long time ago. I'm not for sure, right? So who sets that thing? Does anyone set that thing? Okay, so obviously that was not necessary. And can be removed. So it looks like that must have been for something that we were using before and that we're not using now. I'm not entirely certain. But apparently that's the case. So let's take a look at some of these other ones here. Presumably, at least one of these guys is actually getting used by somebody somewhere. Or not. Debug variable link, then? Maybe? So it looks like tear value is the thing that was using that. And so if we just say that we're not going to use the value tear off stuff at the moment, we would not need that either. And we've never used it. I think we experimented with it a bit and we just never really cared. Because we don't save that stuff, so... So if we just get rid of that, what happens? So it should have worked with Alt UI, but I tried that and it didn't actually work. What's the deal with that? I'm gonna see what happened. Why couldn't I do that tear operation? It was supposed to work with Alt, but it did not work with Alt, and I don't know why, and I would like to know why. So if I run this here, I'm gonna run this, and I say Alt, you know, it doesn't do anything. You know what I'm saying? So what's up with that? So Alt UI is not actually the Alt key. It's some other thing. Is there a reason it's not the Alt key? Let's just make it be Alt down, right? Maybe we didn't have Alt at that time. All right, so now if I have Alt down, okay. All right, so I'll leave that in. I mean, it works. So we'll leave that in there. That was just a case of us not wiring up the input, I guess, because maybe we didn't have Alt at that time, and so it was just confusing. It said we had to keep the ended down, but ended down, so we had to hold down the right button and then click the left button or something. I don't know. It doesn't matter. Point being, it's fixed now. So I'll leave that in there because that seems reasonable to me to keep if it's working. Debug element, I think, is the main thing we use. So I'm pretty sure this is used everywhere, right? Because that's the thing you use for most often. Yeah. So that's good. Let's see here. So that all seems okay, and you know, those things are pointers, so they don't have to be even compiled in. If these types were undefined, it wouldn't matter. So we can basically look at everything except for the debug ID, and the debug ID is just a blind value. So really this thing could be also lofted up as like a dev ID or something, right? And so if I look for everywhere that debug ID is used, if we change debug ID everywhere to just be dev ID, and it's a thing that you're always allowed to use, that seems totally plausible. So I think that's maybe what we'll do as our change. Now, I don't have a lot of time left, so I'm going to make that change, and then we'll probably stop for the day, and next weekend we'll unify these two, because I don't really want to get started on that, because it's not going to finish in time. So I'm going to go ahead and put that into the platform layer. In handmade types, probably. Yeah. So we'll throw that in here. That's going to be a dev ID. And then everywhere that we were going to use a dev ID, debug ID, we're going to use a dev ID. All right. Looks like we're good to go. So now we're almost there. I feel like we could take this time to pretty up some of our debug output too, because as we're unifying these two things, we could kind of clean up a bunch of this stuff if we wanted to as well, I think. So that might be nice. And why are our baselines wrong? Have you noticed that? Like, what's going on there? I feel like our baselines are wrong. I don't know why that's happening, but our baselines are messed up for fonts. And I think you just can't tell because a lot of these things you wouldn't necessarily know, but it looks like we've got some bugs there as well. That's probably something we're gonna have to take a look at some point, right? You can see the dashes, they're floored down there. So I don't know why, right? So I think that's good for today. I'm going to leave it there. And we know exactly what we're doing now. So Dev UI, I mean, I can start pulling some of these things out. What have I got? 5 more minutes left. So I could, I could do this type just for now. Put this into dev UI.h. And just make this be an interaction type that is now unified into the system. And that should only take 5 minutes. I don't think it'll take us too much longer. I'm really just searching and replacing. Guess I might as well do those both at the same time, actually. And sorry for the boredom here, but this is just basically search and replace. Looking forward to adding. I've been waiting a while to do more for coder stuff because there's been some changes that I'm sort of waiting for to do my next big update. But one of the big things I want is remembering the search and replaces that I do so that I can just repeat them. You know what I mean? So I think that's all good now. So I think we're pretty much set to pop here. And I'll call it there. I also would like to know at some point why our positioning is messed up. We probably should fix that. I'm not sure. We must have done some positioning stuff that was, we used to probably have it be positioned relative and now it's positioned absolute, which doesn't correctly account for expansion. Oh, and Ginger Bill, you had that question for after the stream. Do you want the viewer to be able to edit things or just view things? My answer is that I don't think you necessarily want to get too far down the rabbit hole. So I would say don't. Editing is not a thing. It's just viewing. And I guess the reason I would say that is because if you go down the route of I need to be able to edit things, then the data file format that you're going to specify has to be a lot more complicated potentially, because you're basically saying it has to be something usable and but as like an input, a permanent storage format basically. And that just opens up a huge can of worms. So while I do think it might be eventually useful to say, okay, once you make a really great viewer and it's awesome and it does everything we want, you know, then version 2 is we figure out how to update that to something that's usable in an edit sense as well. Great. But I wouldn't do that first because I feel like it would get in the way and overcomplicate things, and it might result in a poorer viewer at first, because it broadens the scope out in a really uncomfortable way. And so I wouldn't focus on that, right? Because it brings in so many other issues and so many other competing concerns, as opposed to just here's how I dump a log of data, which is like very well defined. It's like, what's the easiest way to just specify a stream of data, right? Whereas once you get into all these other things like editable, it's like, oh, well, how does it link up with other things? How do I put IDs in there that tell me that this thing maps this other thing in my program? And like, how do I specify how many there should be or how many you can add or what the possible values of this thing are? Like, all of those things now become important, and before they really weren't. So I feel like it just while it's a good thing to do someday, maybe, it's not a good V1, because I think you should scope it down for V1, get it done and good, and then you can always broaden it out later, right? There's nothing to stop you from adding on and making that a later thing. Do you have any advice or resources to read on shadow mapping implementations? I don't. I've never implemented shadow maps. I don't like them. I feel like they always look bad. You have to do a tremendous amount of work to make shadow maps not look bad. Outdoors in the sun, sometimes it's okay. Even then, I see a lot of really bad implementations. There's a lot of speckling along curved surfaces and stuff, and you have to be really careful. So I would say, yeah. In terms of reading up about it, I don't even know what the latest schemes are. I can't remember which one got used in the witness. It might have been Cascade-based shadow maps, but I can't remember. They're all bad. I don't like shadow mapping. It's especially bad because for direct shadowing, like ray casting is exactly what you want, because it only takes one ray per pixel to determine the shadow of a light source. You know, it's not the same sort of thing as diffuse lighting, where it's very hard to compute ray tracing wise. So I feel like the push towards ray tracing, if it does nothing else, will make it so that we never have to use shadow maps again, and that day cannot come too soon. I can tell you that right now. So hopefully that would work, and then we won't have to care about shadow maps anymore, but who knows, maybe not. There's also problems with, like, you know, I don't know, maybe you're trying to use tricks to get softer shadows by using, like, the shadow map in a convolution and stuff like that, right? So, and that doesn't necessarily work for if you're doing ray tracing. I mean, I don't know. It probably does still work for ray tracing in some sense, because, I mean, you could just still record every ray that you trace back to the light source, recorded into a bitmap, and then blur the bitmap or something, and then use that as a secondary lookup. So, I mean, maybe you still could do it. I don't know. Are you still planning on removing the CRT in the game layer? Yes, actually. I don't know why we haven't done that yet. I think because I haven't gotten around to putting in a cosine function. I would like to do that, though. I nuked the CRT in my project and it reduced its size from 150K to 35K. I did not think it inserted so much cred. It inserts a tremendous amount of crap into your code. Tremendous. Even if you don't use anything. It seems like just the startup code for the CRT in Windows just dumps a truckload of code into your thing. And to be honest, I've never gone through and actually looked at what it all is. All I know is you don't need any of it. So it's pretty much good to just get rid of it, because all of it's useless. Like 100% of it. So yeah, I mean, I don't know. Do you think programming books are worth the effort to read, or is there a better way to learn? I mean, like anything else, it depends on the book, you know? There's probably some books that are worth reading, and then there's books that aren't. So I don't think it's about whether it's a book or not. I think it's whether the book's good. Are we still planning to port to Linux and bare metal Raspberry Pi? Yeah, I would like to it someday, but I mean, we're talking about after we're done. How useful would it be to get additional performance information for the CPU? I know Intel provides some stuff for things like branch prediction and cache misses. It can be very useful. In a game like Handmade Hero, it's not particularly useful because we just don't have that kind of performance concern, really, at least not at the moment. But it's definitely the kind of thing that... if you're doing serious performance work and you're running up against barriers that you don't understand... And when I say don't understand, I don't mean because you're like not experienced enough or anything like that. I mean don't understand as in no matter who you are, if you try to program a CPU to the limits, you will hit things that you don't understand if you can't have analysis, right? And so those CPU counters are really good for figuring out things you don't understand why they're happening. Because you'll hit into situations where you're like, why isn't this thing getting the throughput that I think it should based on my calculations? And the answer just becomes, oh, because of this other thing you didn't think of. And so sometimes those performance counters can help you with that. In Handmade Hero, most of the things that we have that might be performance targets like lighting, they're not really at that point. We are usually in algorithmic optimization territory right now, and so having performance counters like the ones on the CPU are not really going to help us. So we wouldn't care about that for our stuff, but depending on what you're doing, you can definitely get valuable information from that stuff for sure. Will we be avoiding the CRT on Linux in the future? Probably not, because we won't spend very much time on a Linux port. Linux is not really a platform for gaming currently. Like, it's not a place where games get purchased almost ever. And so it's not really a focus of game programmers. Perhaps sadly, it might be nice if tons of people bought games on Linux. They just don't. And so we probably won't spend much time in the Linux version. You know, we'll probably just do like an SDL port or something and be done with it. Because it's not a primary platform. You don't really want to spend a ton of time on non-primary platforms. Except maybe the Raspberry Pi, because it might be fun to do one bare metal platform and do that really cleanly. So, you know, but Linux isn't that. Linux isn't a bare metal platform. How can you determine the validity of a book and its usefulness? I don't know. You have to... people who you trust who have read it. Other than that, I'm not sure you really can, you know? 0LPBM, it's close enough. Supporter, don't think of supporter as being spelled wrong. Think of it as you were spelling it like an internet startup company would. Because everyone knows that supporter, SUPPORTER, is not worth several $1 million of venture capital Series A funding. But supporter, SUPPORTR, on the other hand, better yet, SUPPRT.LY might be even better. Think about it. What's the empty space in the thread debug view? Which empty space are you talking about? Do you just mean like out here? I guess I'll explain what this space is in the hopes that that's the thing that you're talking about. So let me pause and I'll show you. So at the moment, on Handmade Hero, we have, so if you take a look at each of these things here, we have on this CPU 8 like cores, right? And so in here we've got like 1, 2, 3, 4, 5, 6, 7, 8, 9, I guess. I'm not sure how many there actually are because these 2 lanes are empty. We've got 9 slots, if you will, for doing work. And they show up as 2 bars each because like 1 bar is the subfield, like this is do lighting work, and it's inside compute light propagation, right? So I don't know why we chose to draw them that way exactly. It probably could be drawn better than this, but each of these is actually 1 channel. We should probably like stripe them so you can see the channel. So at startup, what we do is we look at the number of cores, I believe, if I remember correctly. Maybe we don't. Maybe it's just fixed. I can't remember. But we create basically queues for doing work. and they're separated out into a certain segmentation. So there's one main thread that runs all the time, and that just has most of the game on it, right? Like stuff that's not performance critical, generally speaking, just all runs in here. So this is the one main thread. Then for parts of the game that are super performance critical, here are a set of threads, and this one's included because it will do work as well. But here are a set of threads. These lanes are just idle. They're not doing anything until there's work available. So when there's performance critical work, like solving the lighting is the main thing we have right now. We don't really have any other performance critical stuff that's just a huge batch of work to do. It goes onto a queue that each of these threads will take work from. So they're all working on the lighting. And that's why you see them show up here. Once the lighting's done, there's no more work to do, right? So they don't have to do anything for the rest of the time. These slots here are actually slots for things that are basically waiting on the operating system. So when we need to load an asset, so we're going to request some asset from the operating system, file load, wait, and process it, they go in here, so they almost never do anything. And that's also why this is oversubscribed. That's why there's, threads for work, 1, 2, 3, 4, 5, 6, 7. There's actually as many of those as you would really have cores, except for maybe one that's available for like keeping this from getting stalled or something. And there's 2 of these that just sit around doing nothing most of the time, except when there's load work to do, right? So we kind of tried to like scale it that way so that we'd not have too much oversubscription. If you're wondering why we don't have anything out here, well, the reason for that is that this right here is actually the end of our work, right? So the end of the game's actual work happens right about here. This is the debug system here, right? And this is us waiting for the GPU to finish. So really nothing goes in here ever, no matter what, because there's nothing. Once we've done all the work we can do, we're stalled on the GPU waiting for it to finish the previous frame so we can start feeding it a new frame. So that empty space is never going away. This empty space might get filled up, this part down here, might get filled up more as we push, if we end up with more heavy work to do, it'll get filled up more. But otherwise, it will also stay roughly the way it is right now. Am I already testing JI? No, I don't have a build of JI at the moment. When updating the anchor points, does this mean the HHA file has to be recompiled each time that happens? No, because the HHA file itself just has slots for that, so it'll just get written into the HHA file. It'll just be a write, exactly as we do it now when we import an asset. How would you change the work scheme for mobile platform where we're concerned about battery usage? Well, I wouldn't, because basically, like, there is no such thing as being concerned about battery usage when you're making a game in the sense of work distribution. The reason I say that is because you either have to do the work or you don't. So the only thing you can really do in a game if you're concerned about battery usage is do less, right? There's nothing else you can do. So what you would have to do is say, look, we just turn the lighting off if we're worried about battery usage or something. I mean, there's nothing else you can do. Because if you have to do the lighting, you have to do the lighting. You can't do it if you could do it in a way that took less power, you would have done that originally, because that's just going to be faster and better anyway, right? So that's a nonsensical question in a lot of ways. You can't change the work scheme for a mobile platform for battery usage. You have to change the game design, right? You have to change it so that you don't have to do that work. Because if you have to do the work, you have to do it this way, which is max cores all doing as much work as you can. Because that's the only way to get the lighting done on time. If you could have done it with less, you would have and should have, right? And so if you're in a situation where you're like, this is too much work to do for a mobile game because it uses too much battery or something like this, then you just have to change the design of the game to make it so that those things are not required, right? Those things have to not be critical. That's really the only thing you can do at that point. Arif, can new lighting propagation be computed while doing GPU doing so? So no, and the reason for that is because this was all the lighting that we had to do. So it's fast enough on this CPU. If we needed more time to do light propagation, this bar just moves down. The reason we're waiting for the GPU is because we were done quick. We finished fast. We don't have any more lighting to compute. So we could crank up the lighting samples and take more time. But you know, that's just adding work for no reason. If that makes sense. Which doesn't seem like a good plan. Something happens where I can't move. What did I do? I don't know what I did. It's going to be nice to have our characters in here without all the weird, like, giant cat, dismembered cat thing. So I'm going to be happy when we finish that little debug UI. Or editing UI, I should say. Uplink coder, we can only start to render if the lighting is done. No, actually, so that's not true. So the GPU is an asynchronous processor, and so what actually happens is the GPU is busy computing the frame from the previous submission while we're doing the lighting for the next submission, right? So remember, this profile doesn't show us any profiling for the GPU. So when we look at one of these things, what we're seeing here is the CPU's perspective. So it knows it did this work, and then it knows it sat around waiting for the GPU to finish, right? What that means is the GPU was actually working the entire time. Because during some part of this, it was working on the last frame, and during some part of this, it's working on this frame, right? But what we know is it's taking a full, like, 60th of a second to do stuff. Now, that's not really true either, because since we're in VSync, we know that everyone could have finished early and might just be waiting around, right? So the GPU is probably waiting on the VSync here too. And it's not bad to be waiting, for have everyone waiting around. It means everyone was fast enough. Everyone went fast enough to finish, and now they're just waiting. But if we weren't, if this is actually the amount of time the GPU is actually taking, then there's still nothing else we could do because we finished all of our work. We can't overlap with the GPU anymore because we are completely overlapped with the GPU, right? The GPU is cruising along, rendering the last frame while we're doing this stuff. We submitted the frame here. This is where we submitted the frame, right? Or maybe back in here somewhere is a little bit more accurate about where we submitted the frame. Technically, we told it what the frame was here, but it's probably been working on it somewhere here, and then it took it, and who knows, right? I mean, but we gave it all the information it needed at this point. And who knows when it started? We don't know. Probably right in the middle, but hard to say. Depends on how long it takes to process the frame on the GPU. We could go look at, like, Nsight would probably be able to show us how long it was taking. I read your article on the manipulation tool work you did on the witness, and it helped me debug my problems. Do you have a good way to manipulate rotation? Is it to ray test on a sphere and then take the D mouse hit and see how long the delta arc is on the specific axis? Usually for rotation, the way I like to do it is I like to take whatever the plane is that's tangent to the rotation axis, do the hit on there, and then project to see where I would be on the ring. That's how I like to do it. And you need two cases. You need one where the plane is facing you and one where the plane collapses to a line. And then I use a band, basically a box, and I use where you are along that line. Because once the plane collapses, then you don't want to use a ring-based manipulator anymore. If that makes sense. All right. Could you get Insight to work and do the help thing? Yes, we have Insight working now, and it works quite well. They gave us an updated version, and it works. No, I'm sorry. That wasn't why it worked. It worked because we had to completely uninstall and then reinstall. That's what they told us to do, and that worked. So there was some kind of weird, like, you can't install an Insight on top of the existing driver. You have to uninstall all the drivers and all of Insights and then reinstall or something. It was some weird, like, installation problem. So we did that, and then it worked, and now we've used it multiple times in the stream, and it seems to work really well. Like, we've been able to, like, go in and look at textures and figure out that we weren't downloading something or whatever. So, like, it's been good. It's been good. All right. Thank you everyone for joining me for Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code, so you can follow along at home. I'd like to finish up that edit UI next weekend, hopefully, so that we can snap all our stuff together and start putting a bunch of stuff into the game. It's really the main thing I think that's keeping us from giving a thumbs up to the like asset import pipeline, because it seems like everything else is working. We'll see when we get there. Maybe there's some things we're forgetting, but that's the big one is just that annotation part. We just didn't have it, and so now we're working on getting how do we put those things in there. So we have a little more work to do. We got to get that UI working, and then we may need one more weekend because we want to have a permanent storage format for it, some kind of text file we can read and write that gets stored off with a PNG so we can rebuild everything from scratch anytime we want to. In case we want to change the HHA format, we don't really want the HHA format necessarily to be our permanent storage format. That maybe not be a good idea. So having a way to put a backing store on there is probably something we want to do too. But it's pretty good. Looks like we're coming up on Christmas here. Which, of course, is also in the game Handmade Hero, because Krampus, of course, visits around the Christmas times. And so that's a good time to be finishing up that, and then maybe we can basically say that we're starting off the new year with weird game stuff, implementation stuff that we want to do, and that's, you know, always kind of a good breaking point, is around the holidays. Around the new year. So anyway, that's it for today. Hope to see you back here next week. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.